You guys are wrapping up, finally, 6-1s, part 3. All these all go together. We're still dealing with the graphs of sines and cosines. But this time you're going to learn how to write the equations from the graph. So now, instead of being given the equation, you're going to be given the graph or information about the graph, and you are going to have to write the equation. So just to make sure that we review the summary of the concepts that we talked about last time, of course, the general equation is y equals a sine bx plus c plus d, or cosine. Of course, a and b can't equal 0. Remember, a is your amplitude, okay? It's the absolute value. Vertical shift is d. Your period is 2 pi over the absolute value of b. Your phase shift is negative c over the absolute value of b. And y equals d is your midline. Those are all things that we've talked about already. And those are the items that affect the equation of your sine or cosine function. And what you're going to do is you're basically going to use this information to plug it into the general form. Now, one thing that you guys also do, be aware of is that, remember, there was the other way to write these equations, which was y equals a sine b, the b pulled out, then x minus c plus d, yes? Where this actually indicated your what? It indicated your phase shift, okay? So another way you could approach this is you could, if they give you all your information, you could write it this way, but then distribute the b through to get it into the general form, okay? This is not general form with the b factored out. The original was in the red as the general form. So depending on what you're given, you could start this way and then just distribute the b over and get it in general form, okay? So don't forget about that. So let's go into it. We're gonna start off from information. That's the first flap. It says we're gonna write a sine function given that the amplitude is 3.75, the period is pi over 2, and the phase shift is pi over 4. Okay, so we're given all this information. We need to write a sine function, which is in the form of y equals a sine bx plus c plus d. Okay. Yeah. All right. Sorry. A is the what? Amplitude. We have that piece of information, so we can go ahead and say this is y equals 3.75 sine. We're 1/4 the way there. Okay? We're 1/4 the way there. Now we're told, b is associated with the formula 2 pi over b, correct? That represents the what? The period. Well, we know that the period is equal to pi over 2, is it not? So we can set up an equation that basically says that 2 pi over b should equal our period, which is pi over 2. And now that we have this equation, we can solve for b. How do I solve something like this, a proportion? Multiply across? Straight across? Diagonally, right? Yeah. You multiply 2 pi times 2, which is what? 4 pi, and then you multiply b by pi, and what's that? B pi. How do I solve for b? What's 4 pi divided by pi? So b is equal to 4. So that means that b is 4. So now I have 4x. Now I'm halfway through writing the equation of this sine function. Have I lost anybody yet? I knew to use 2 pi over b because it said the period was that. I can use the formula, set them equal. Now the phase shift is pi over 4. That is equal to what formula? What's the formula for phase shift? Over the absolute value of b, right? What's b? We just found it. 4. So right now I have pi over 4 equals negative c over 4. How do I solve this? Do the same thing I did to the other one, which is multiply across. Oops, wrong one, sorry. That way. 4 times pi? 4 times negative c? How do I solve for C?
Divide by -4.
And what's 4 pi divided by -4? And that's your value of C. Do I have a D? What did D represent? The vertical shift. Does it say anything about a vertical shift? No, so then that would be 0. So I could put a plus 0, but I don't need to. And that's my equation. Questions? Okay. Remember how I showed you, I said that, you could do it the other way where you factor out the B. If I did that, it would have been 4 parentheses x. Our phase shift was pi over 4. It was a positive pi over 4, which means that we went to the right pi over 4. But when we write it, we have to be careful because to indicate that we're moving to the right, when it's inside of an equation, it needs to be a what?
Negative.
It needs to be a negative. So this would be a negative pi over 4. And remember what I said, to get into the general form, I need to take that b and multiply it through. What's 4 times x?
4x.
And what's a 4 times a negative pi over 4? And that's what we have there. Okay? So you could do it either way, whichever way is, easier for you, whatever. Questions? Look at this one. We're going to write a cosine function that has an amplitude of 3, a period of pi over 4, a phase shift of pi over 3, and a vertical shift of 2. So I'm writing a cosine function. Do you want to do it with the b factored out or the b already in?
B already in.
B already in? Okay. All right. What's a going to be? 3. It is your amplitude. The only time that a won't be 3 is if it says that it was reflected over the x-axis, because then that means it would have been a negative. Okay? But it would say that somewhere inside of the problem. Okay? Cosine. Now I need to find b. What formula involves b? 2 pi over b. And that's going to equal 4 pi. 4 pi over 1. Cross multiply again. That's 2 pi times 1 equals 4 pi times b. How do I solve for b? What happened to those pi's? And what's 2 divided by 4? So b is 1/2. We okay? Phase shift. I should set that equal to what? Negative c over b, which is 1/2. Okay? Now, from here, it's more of a preference of how you want to solve this. You can either cross multiply now, or you can keep, change, flip, and then cross multiply. Which one you want to do?
Cross multiply now.
Okay, cross multiply now. All right. So I'm going to multiply. What's 1/2 times pi? 1/2 pi. 1/2 pi is the same thing as? And then that's going to equal?
Negative
3c. How do I solve for c? Okay. So I'm still going to have to do what? Keep, change, flip. Keep, change that division to multiplication, and then flip -3. What is -3 flipped?
1/3.
And how do I multiply fractions? So this is negative pi over 6. And let's see. What's my vertical shift?
2.
And is that plus or minus? questions? Let's take a look at this one. You guys did on your desk. So you are writing a sine function that has an amplitude of 1, period of 2 pi, a reflection over the y-axis, ooh, new, a phase shift of 2 pi over 3, and a vertical shift of negative 1. So y equals a sine bx plus c plus d. What's a? 1. I really don't have to put the 1, but I did put it, so I'm going to keep on rolling. 1 sine b. Hopefully you said 2 pi over b equal to 2 pi. Did you do that? It's the same thing as saying 2 pi over 1. I can cross multiply. I can recognize that b, like these have to be equivalent. B has to be 1. This is a 1x. Now it says it's a reflection over the y-axis. A reflection over the y-axis means that I need to have a negative somewhere in this problem. Okay, I got 2 1s. In front of the x, yes, because it's a y-axis, that means that you're making your x's negative, so it has to be on the inside. If it was on the outside, that would have been a reflection over the x-axis. Now let's find our c. Did you do your 2 pi over 3 equal to negative c over b? Well, b is 1, and remember, it is the absolute value of b. Since technically b is a negative 1, it still is going to go in as a positive. When I cross multiply and solve, c is equal to what? And that is what you plug in for c. Like when you do it this way, whatever you get for c is what goes into that spot. You don't have to worry about doing any type of change or anything. That's when the b is factored out. You have to worry about that. Do I have a d?
Negative 1.
And that is our equation. Beautiful.
Coach, is the homework gonna be this easy too?
Yeah, so like the first, so like the first 4 are just like this. I tell you which function to write, what's the amplitude, here's the amplitude, here's the period, here's the phase shift, here's the vertical shift. Give me my equation. Yes. Good. All right, let's do it from the graph. Now your homework is more of these though. And this is like what you would have had in Khan Academy as well. Okay, it's what you would have had in the Khan. The hint that I give you is you need to identify key features of the graph to find A, B, C, and D. When you're doing it from the graph, you have to identify key features and fill in those values. So we're going to do 2 together, and you guys are going to do 1 on your desk, okay? So we're going to write the cosine equation for the following graph. So as we can see, first off, it is 1 full cycle. It's 1 full period. Sometimes you won't be given a full period, and so you kind of have to, do a little bit more like the next example that you guys see in your foldable. But always make sure you look at what you have. You're like, okay, I have 1 full period. I start here, and I end here, so that is 1 full period. And since it is 1 full period, how long is this? How long is it from start to end? 2 pi. So that 2 pi represents my period. Remember, period is basically the length of time it takes for the graph to start repeating itself. So my period is 2 pi. I needed to know what my period is to find which variable? To find b. Okay. Now, let's see. Since this is a cosine function, normally where does cosine start on the y-axis? 1. It doesn't start at 1. It starts at what? 2. Starts at 2. Did it look like the graph got shifted up, or did it look like it got stretched? It definitely got stretched. So it didn't get shifted. It got stretched, which affects which part? Your amplitude, your A. Okay? And looking at this graph, remember, your amplitude is the distance between your midline and the highest point, or your midline and your lowest point. What's my midline here? 0. It's what basically cuts the graph in half. So one way to find the amplitude is you can say, okay, let me find the midline and then figure out how far is it from the midline to my highest point. What's that?
2.
It's 2. And because cosine normally starts at 1 and go down and then back up, this graph does the exact same thing, starts up and then goes down, so we know it's not reflected. over the x-axis. So 2 is going to be my amplitude. Did it get shifted over any? No, it still intersects the y-axis at its high point. It didn't get shifted over, so there's no phase shift. And since my midline is still at 0, there's no vertical shift as well. So I have pretty much all my information. So with no phase shift, there is no C. And with no vertical shift, there's no D. So I only have A and B here. Let's find B. Since the period is 2 pi, I'm going to set that equal to 2 pi over B. Same thing as saying 2 pi over 1. What's B? 1. And I already know my amplitude is 2, and it wasn't reflected over any axes or anything like that. So my A is going to be 2. So I have everything I need. Y equals 2 cosine x. Another way you can find the amplitude is you can take your maximum value, like what's your highest y value, minus your lowest y value, and divide it by 2. That's another way you can find your amplitude. What's my maximum value, y value? What's my minimum? So 2 minus a negative 2, that ends up being a plus, so then that becomes 4 over 2, which is just 2. And that's what we got for our amplitude. Your vertical shift, your D, can be found as well by doing your max plus your min divided by 2. The same y values. So that would have been 2 plus a negative 2. What's 2 plus a negative 2? What's 0 over 2? So there was no vertical shift. There was no midline was 0. That's another way. So it's like if you're like, Ms. Anderson, just give me the formula. I can do this. There's formulas to find A and D. You already have formulas to find C and D. Okay? Questions? Before we get to that next example, I want you guys to try this one on your desk. Try this one on your desk. Okay. Let's start off with the amplitude, or the A. What'd you get for A? 1. How'd you do it?
The max 3 minus 1.
Okay, so you did the max minus the min over 2. So that's 2 over 2, which is 1. Okay, good stuff. So right now I have y equals 1, which I don't have to write, but I'm going to write it for the emphasis of what we're doing. Now let's find our B. What was the period? Pi. It started here and it ended here. It would have continued to keep going at this point. So yes, pi was my period. What did you do with pi? When you cross multiplied and solved, you got that B equals 2. Very good. So this would have been a 2x. Yes?
Yes.
Now, normally sine starts at 0, 0, and then it continues to go up and then back down and so on and so forth. Did this graph get shifted to the left or the right any?
No.
No, it didn't. So that meant that it had no phase shift, correct? No phase shift. But it did have a vertical shift because it doesn't start at 0, 0. Where does it start?
2.
It's 0, 2. So what was your vertical shift? What was your D? It was plus 2. Even if you couldn't recognize it from there, you could have done the other formula, which is max plus min divided by 2, which is 4 over 2, which is 2. That's how you find your vertical shift. So that is your equation. Y equals sine 2x plus 2. Yes, ma'am?
Is there not a horizontal shrink?
There is a horizontal shrink.
How do you think that?
A horizontal shrink is when the graph is basically squished in.
Right.
So this will be an example of a horizontal shrink. Yes.
Is that not in our equation?
It is what the 2 represents.
Okay.
So let's look at this last one that's in our notes. I want to do this one with you guys because we're going to write a sine function and a cosine function for this graph. Now the beauty about this is that to write a sine and a cosine function, the A, the B, and the D are all the same for both sine and cosine. So when you write a sine function or a cosine function, the A, the B, and the D all stay the same. It is the phase shift which changes, okay? Because cosine starts at 1, goes down, then comes back up. This is cosine. But sine starts here, goes up, down. It goes like this, okay? So when you look at this, when you look at them overlap, doesn't it look like the sine function was shifted over or the cosine function was shifted back? Okay? That's why a lot of their stuff is shared, like the same B, the same A, the same D, because it's literally they are the same graph, they just got shifted. One is just shifted than the other. Okay? So, let's start off by writing our sine function, because if we notice, the graph intersects at 0, 0. Okay? And when we look at this, is this a full period? No. What do you think happens after 2 pi? It goes up, then comes back down. So this was actually how much of a period? It was half of the period, okay? So a full period is actually how much? 4 pi. And remember how it was like, oh, this is half of the period? That's your B. Your B is a half. If you don't believe me, set 2 pi over B equal to 4 pi. When you solve this, B is what? 1/2. So when you recognize how many cycles actually occur between 0 and 2 pi, remember that is your B. That's your B. Your B tells you how many cycles occur between 0 and 2 pi. That was only half of a period. What's my amplitude?
3.
Your amplitude is 3. Did this graph get shifted up at all?
No.
Or down? It didn't. My midline is sitting right there at my x-axis. So that distance is 3. Now, normally, doesn't sine start up and then go down? But this one starts down. So it's a negative. My amplitude is a -3, but my A is -3. Since I started at 0, 0, I have no phase shift for my sine graph, and it didn't shift up or down, so I don't have a vertical shift neither. So I have my sine function. Y equals -3 sine 1/2 x. Questions? Now to write the cosine function. Remember what I said, cosine has the same A, the same B, and the same D as your sine function. Cosine and sine have the same what?
A, B, and D.
So if I ask you to write a cosine function after you wrote a sine function, those 3 things are going to stay the same. So I already know that my cosine function is -3 cosine 1/2 x something plus 0. The one thing that's the difference between sine and cosine is that phase shift. Okay? Now, this is usually the hardest part for students, and I'm going to do my best to try to explain it in the best way possible. Best way possible. Cosine intersects, the original graph of cosine intersects the y-axis where? at 1. Okay? But because this graph got reflected over the x-axis, where should cosine technically have started?
Negative 1.
At negative 1. Okay? But it is not at negative 1. Where's that now low point on the graph? Where is it now located? That's the y. Where is it on the x? It's pi. It's right here. It's that point. Okay? I have moved from being on the y-axis to this point. How far is that? Pi. The distance it takes from the y-axis to get to that point is your phase shift. I'll say that again. Normally cosine starts at 1. But because it got reflected over the x-axis, it would have technically started at negative 1. But the graph that we're given does not start at negative 1. Or that low point is not at negative 1. It's technically at negative 3 because it was stretched. But it was also shifted over to start at pi. That shift is your phase shift. So since my phase shift, the distance it took before it actually got to that starting point, normally it would start it here, but now it starts here. No. Now it starts here. So since my phase shift is pi, to actually find the c that goes in this part of the equation, I need to set it equal to negative c over b, which is 1/2. Pi is the same thing as saying pi over 1. So when I cross multiply, this becomes 1/2 pi, or pi over 2, is equal to a negative c. What is c? It's a negative pi over 2 because I would divide by a negative 1. So c, the part that goes into my equation is negative pi over 2. And there you have both your sine and your cosine function for this particular graph. A, B, and D are all the same, but to actually find the C, which is the one thing that differs a sine graph from a cosine graph, the easiest way to do it is to figure out how far from the y-axis do you reach a low point, if it's been reflected, or a high point if it hasn't been reflected. That distance, which you see in green, is your phase shift, and that's what you set equal to negative c over b.